Hey guys. Okay, now we are going to do lesson 9.2, testing difference between two means with obviously a t-test. And you've known this from the past. What does a t-test mean? Well, it means when the population standard deviations are unknown. These are your three assumptions. Again, you can pause this video to write these down. Your samples are obviously random. Your sample datas are independent of one another. And if you have less than 30 things, 30 people, 30 tests, the population must be approximately normal in order to complete this t-test. Now, at the time I'm making this video, I know you know what's going on in the news right now is the coronavirus. And I don't know if you know, they're doing this study on what's called hydroxychloroquine. And it's the malaria drug that they're giving to people who have the coronavirus, and they're believing it to actually be helpful. Donald Trump made a big statement about it, and then everybody's kind of been fighting against him on this and saying, oh, there's not enough sample because in China they didn't think their test was done randomly enough, or it was just based off of assumptions. Well, I was looking at, if you would like to Google it, it's kind of interesting, but this was, you can see my Penn State, University of Pennsylvania is going to test this coronavirus drug, hydroxychloroquine. And the way they're doing this is they're going to do a study on 400 people in 3 different sub-studies. The first is going to compare the medicine against a placebo. And the second is going to compare a high dose versus a low dose and see if the people get rid of coronavirus quicker. And then the third will study how healthcare workers treating infected patients with a placebo drug versus them not having a placebo drug, which could it prevent the infection. Very interesting. There's definitely no population standard deviation on this one, so they're definitely probably going to be doing a t-test. But I'm just interested to see what will happen. I just thought that might be cool because that's what we're doing right now, y'all. We're just comparing means. All right. So you should have already printed this out. This is testing the difference between two means of independent samples using a t-test. In your calculator, you are obviously going to go to Stat, Calc, to Sample t-test. Okay. So when we don't know, and again, that's when we don't know standard deviation and standard deviation 1 and 2, the population standard deviations for those two groups is unknown. We don't know if this drug is going to help. We've never tested it before, okay? There's this new word you're going to hear. It's called pooled, and you're going to see it on the calculator, pooled. And what pooled stands for is that it assumes the population standard deviations are not equal. Standard deviations are not equal. So we are going to assume they're not equal. We're going to assume there's slight difference when we do our homework tonight. So let's do an example, and then you can spend the rest of your time doing your 4 problems of homework tonight. Whoopsie-doo. All right. A study was done to see if there's a difference between the number of sick days men take and the number of sick days women take. I love all these male-female things. A random sample of 9 men found that the mean number of sick days taken was 5.5. Now, they only tested 9. So they're definitely having to say that there's a random sample. The standard deviation of the sample was 1.23. Random sample of 7 women found that the mean was 4.3 and the standard deviation was 1.9. At the 0.05, can it be concluded that there is a difference in the means? So let's go and write this all out. Step number 1, what's our HO? What's our HA? Well, we're still thinking that the means are equal for the men versus the women. But our claim is that, can it be concluded there's a difference? Can we say that, no, they're not the same? Okay. And over here, I just want to write down what I have so far, what I've gotten my little statement here. I've got that I tested 9 men, that the mean for sick days, that their average sick days was 5.5, and that their standard deviation, again, that's an SX1, is 1.23. That's for the sample. For women, I tested 7 of them, found that their sample standard deviation was 4.3. I'm sorry, their sample mean was 4.3. Their standard deviation was 1.19, okay? And we're testing at the significance level of 0.05. So step number 2, our significance level, 0.05. Step number 3, use your calculator, get that p-value for me. Again, there is a way to do it by hand. I just thought you might like to kind of jump to the gun and not do it that way. So stat, tests. Oh, I think I hit stat calc. My bad. Stat tests. Ooh. 2 sample t-tests because we don't know. Let me move this over so you can see it. There's no glare. So we're going to go to stats. Our X1 is 5.5. Maybe I can move it over here so I can read what my stuff is. There we go, 5.5. Our SX is 1.23. Our N is 9. Our X2 is 4.3. Our SX is 1.19. Our N is 7. We are testing that they're different. Is it pooled? Yes, it's pooled. They're not the same. Calculate. And I get a p-value of 0.069. Is 0.06 greater than or less than 0.05? Well, it is greater than 0.05. So step number 4, we can't reject. Boo. Do not reject the HO. And then number 5, there's not enough evidence. Sorry, women. I thought we would be less sick or there'd be a difference, but there's not enough evidence to support the claim that there is a difference between the number of sick days of men and women. I know this seems long, and that's pretty much the longest part right there is number 5. But that's part of being a statistician. You've got to explain to the people you're working for what is going on with all these numbers. Okay, what does that mean? So try your homework, page 503, take a picture, send it to me. Bye-bye.